Hello friends, myself Parth Patel and today we will be presenting a session on De-Broglie's law and Heisenberg's uncertainty principle. So the introduction to the scientist part will be explained by my friend Sarthak Bagle. Demonstration of the De-Broglie's law and Heisenberg principle will be given by my friend, will be given by myself. The PPT is made by my friend Tejas Dash. So let's begin.
So hi friends, let's begin with the introduction to scientist, that is De-Broglie. So friends, Louis Victor Pierre Raymond from 15 August 1892 to 19 March 1987 was a French physicist and aristocrat who made groundbreaking contributions to quantum theory. In his 1924 PhD thesis, he postulated the wave nature of electrons and suggested that all matter has wave properties. So, friends, this concept is known as the de Broglie hypothesis, an example of wave particle duality, and forms a central part of a theory of quantum mechanics. De Broglie won the Nobel Prize for his best contribution in physics in the year 1929, and after this, wave-like behavior of matter was first experimentally demonstrated in year 1927.
So now we will see De-Broglie's principle. In quantum mechanics, matter is believed to have both like a particle and a wave at a microscopic level. The particle behavior of the matter is obvious. When you look at the table, you think of it is a solid stationary piece of a matter with a fixed location. At this microscopic scale, this holds true, but when we zoom into subatomic level, things begin to get more complicated and matter doesn't always exhibit the particle behavior that we expect. This non-particle behavior of the matter was proposed in 1923 by Louis de Broglie, a French physicist. In his PhD thesis, he proposed that particles also have wave-like properties. Although he did not have the ability to test his hypothesis at the time, he derived an equation to prove it. The equation was actually a combination of the two other scientists by Albert Einstein and Max Planck. In short, the de Broglie's hypothesis proposes that matter can exhibit most particle and wave-like behavior. Wavelength is equal to h by p is equal to h by mv. So you can see the picture.
So, hi friends, again I am here to begin with the introduction to scientist, that is Heisenberg. So, friends, it is the image of this scientist. So, friends, Werner Karl Heisenberg from 5 December 1901 to February 1976 was a German theoretical physicist and one of the key pioneers of quantum mechanics. Friends, he published his work in year 1925 in a breakthrough paper. He is also known as uncertainty. He is also known for the uncertainty principle. So, also, he was awarded in the year 1932 for the Nobel Prize in Physics for the creation of quantum mechanics. Heisenberg also made contributions to the theories of the hydrodynamics of turbulent flows and the atomic nucleus, ferromagnetism, cosmic rays, and subatomic particles. He was a principal scientist in the German nuclear weapons programming during World War II. Following World War II, he was appointed the director of Kaiser Wilhelm Institute for Physics, which soon thereafter was renamed the Max Planck Institute for Physics.
So now we will see what is Heisenberg's uncertainty principle. This is the image, and Heisenberg's uncertainty principle states that for the particle exhibiting both particle and wave nature, it is not possible to accurately determine both position and velocity at the same time. The principle is named after a German physicist, Werner Heisenberg, who proposed the uncertainty principle. In the year 1927, this principle was formulated when Heisenberg was trying to build an institutive model of quantum mechanics physics. He discovered that there were certain fundamental factors that were limited our action in knowing certain quantities. This principle basically highlights that simultaneously measurement of a position and the velocity or momentum of microscopic matter waves will have an error such as the product of the error in measurement of the position and momentum is equal or more than an integral multiple of the constant. In short, Heisenberg's uncertainty principle imposes a restriction on the accuracy of simultaneously measurement of position and momentum. The more precise our moment of a position is, the less accurate will be our momentum measurement and vice versa. This is the picture where you can see the electron particle position and electron wave momentum. Delta E into delta T is always greater than h by greater than or equal to h by 2 pi.